In this lesson, we will continue to study other properties of rock-forming minerals. First is the first pair, tenacity and brittleness. Ductility refers to a mineral's ability to undergo plastic deformation when subjected to external force. Examples include native gold, native silver, and native copper. Legend has it that Ji Hong, an alchemist from the Jin dynasty, created the process of making gold leaf. This process involves meticulously processing pure gold through more than 10 steps, transforming gold pieces of various sizes into uniform, paper-thin gold leaf as thin as a cicada's wing. It has become a special, traditional craft of the Chinese nation. This technique can transform a single gold ring into gold foil equivalent to the area of a basketball court, colloquially known as 1 caddy of gold covering 1 mu of land. Brittleness, conversely, refers to a mineral's tendency to easily fracture when subjected to an external force. Examples include galena and wolframite. Scratching them with a small knife produces powder and small fragments. However, when scratching ductile minerals with a knife, the scratched surface of the mineral will leave shiny grooves, without producing powder or fragments. The second pair, elasticity and flexibility. Elasticity refers to a mineral's ability to bend when subjected to external force, and then return to its original state once the force is removed. Examples include mica and asbestos. Flexibility refers to a mineral's ability to bend when subjected to external force, but not return to its original state once the force is removed. An example is chlorite. Some minerals, such as magnetite, megamite, and perovskite, possess magnetism. Some minerals, when exposed to external energy, such as irradiation from ultraviolet rays, X-rays, and radioactive rays, or when struck, rubbed, or heated, can emit visible light if stimulated. Common luminescent minerals include diamond, scheelite, and fluorite. Luminescence is one of the important characteristics for identifying such minerals. It can be used for mineral prospecting or ore beneficiation. In the previous section, when introducing the Mohs scale of hardness, we mentioned that talc has a Mohs hardness of 1. It is the softest rock-forming mineral. Therefore, it can be scratched with a fingernail. It is white, often with a slight bluish or greenish tint due to impurities. Its streak is white. Its surface exhibits a greasy luster. The second type, graphite. It has a Mohs hardness of 2. It is a gray-black, opaque solid. It has a low density and a greasy feel. It is chemically stable, insoluble in water, dilute acids, dilute alkalis, and organic solvents. It has excellent high-temperature resistance, conductivity, thermal conductivity, lubricity, chemical stability, plasticity, and thermal shock resistance. The third type, calcite. It has a Mohs hardness of 3 and is the main component of limestone. It occurs as rhombohedrons or hexagonal prisms. It is colorless or milky white, with 3 directions of perfect cleavage. The fragments formed when it is struck are all rhombohedral. It reacts vigorously with cold, dilute hydrochloric acid, producing bubbles. The fourth type, dolomite. It has a Mohs hardness of 3.5 to 4. It is grayish-white or pale pink. Its aggregates are massive or granular. It also has 3 directions of perfect cleavage. Unlike calcite, dolomite powder reacts weakly with dilute hydrochloric acid, producing slight bubbles. Quartz has a Mohs hardness of 7. Its crystal form is hexagonal, prismatic, or pyramidal. Its aggregates form druzy clusters. Pure quartz is colorless and transparent, with a vitreous luster. It has no cleavage. It exhibits conchoidal fracture, and the fracture surface has a greasy luster. It is chemically stable. It has strong resistance to weathering. Quartz stone is a new type of engineered stone, artificially synthesized from over 90% quartz crystals, combined with resin, or other trace elements. It possesses advantages such as being scratch-resistant, non-staining, durable, does not wear out easily, non-combustible, non-toxic, and radiation-free. Garnet has a Mohs hardness of 6.5 to 7.5. Its common crystal form is a rhombic dodecahedron. It has a vitreous luster. It has no cleavage. It exhibits conchoidal fracture, and the fracture surface has a greasy luster. When fractured under pressure, it produces distinct, irregular, small pieces. Garnet-S color is influenced by its composition, exhibiting a variety of colors. Pyrope often appears red. Almandine appears dark red and is often used as an abrasive. Spessartine, conversely, appears yellow-orange, also known as Fanta garnet. Grossular often appears emerald green. Diamond has a Mohs hardness of 10. It is the hardest naturally occurring substance in nature. It exhibits an adamantine luster and shows fluorescence. It is an allotrope of graphite. Therefore, graphite can be transformed into synthetic diamond under high temperature and pressure. The world's largest diamond, the Cullinan diamond, was discovered in 1905 in the Kimberlite Pipes, near Pretoria, South Africa, weighing 3,024.75 carats. It was equivalent to the size of an adult man's fist. Several groups of minerals have relatively similar physical properties. Next, let's take a closer look at their similarities and differences. Both muscovite and biotite are platy, with one direction of perfect cleavage. The difference is that muscovite is highly insulating. It has strong resistance to weathering, while biotite has poor insulating properties and is prone to weathering. Orthoclase and plagioclase both have two directions of cleavage, with very similar cleavage angles. Orthoclase is often flesh-colored and is found in acidic igneous rocks. Plagioclase, conversely, is mostly grayish-white and is often found in basic and intermediate igneous rocks. Kaolinite is named after Jiaoling village, near Jingdezhen, Jiangxi province, where it was first discovered. Dry kaolinite readily absorbs water. After absorbing water, it does not swell but becomes plastic. Therefore, it is a primary raw material for the ceramics industry. Montmorillonite swells in volume when it absorbs water. It is the main active ingredient in the anti-diarrhea medication Smecta, montmorillonite powder. Amphibole and pyroxene are both dark-colored minerals. Both have two directions of cleavage. Amphibole is commonly found in acidic igneous rocks and metamorphic rocks, while pyroxene is often found in basic and ultrabasic igneous rocks. Through this lesson, we have become acquainted with many common rock-forming minerals. In the next lesson, we will learn together about igneous rocks among the three major rock types.